Hello there, today we'll be doing target sum, another 2D dynamic programming problem. It's very similar to coin change, buy time with stocks, and these two types of problems. So let's just, this is number 108. So in this particular problem, we are given a list of numbers, and we're supposed to try to make a target, whether we add or subtract. So based on the index, we'll have a different total. So that's where the 2D comes into place. So dp, our dp is going to be equal to the index and the total. That's the difference. And our value is going to be equal to the number of ways that it is possible to get that particular from that particular index and total, right, to get that target. So if we create a DFS call, I and total, this is pretty much similar to all the other problems. Length of nums. If we reach the end, return 1 if target is equal to total, else 0. Elif, it's in the DP, so that means what we're going to do is return the DP of the item. Then we could either just create our DP, if that's not possible, make a recursive call, and that's going to be I plus 1, take the number, or not take the number. Well, and not take the number. So that's how we get all the options to get to the end of the I tree. So return DP of the I total. Then all we need to do is just return the call DFS of 0, 0, and we're good to go. So let's run it. And submit. Perfect. This one seems to be a lot slower, just might be the problems. But there is something that we should note for what we've learned today. What we've learned today here is identify your base cases, identify your variables that you will be needing to find a number of ways. Here it is the item and the total, and from there you get different number of ways. So what is the O of n time? Well, the O of n time is how big the target is. One way to make sure that speed things up to remove this DFS call is to identify the biggest total number, and if it is out of bounds with the targets. If it is out of bounds, we can immediately finish this particular problem without doing any DFS call, making our code much faster. And that total limit is the sum of all the numbers of the nums, the positive and the negative item of it. So basically, if we had 1, 1, 1, 1, the max number would be 5, and the minimum number would be negative 5. So we could make that call. So max num is equal to the sum of nums, and min num is equal to the negative of max num. And if target is greater than max num, or target is less than min num, we can return 0 immediately. So let's run the code and submit. Okay, still pretty slow. Don't know what's going on there, but this should have made it a little bit faster. So anything else about this problem? So we found out our base cases, and we found out how to create all the possibilities, which is to take the number, get the next one, or remove the number, get the next one, based on the particular problem itself. And that's how we came up with this DFS call. Another way to think about this problem, to slow things down a little bit so that we can slowly understand this problem, is to make sure that we either we identify what we're going to do. In our recursive case, we're going to take +1, or we're going to have a -1, and this is our index, and then we move the index, and we can either pick 2 or pick 1, or even just take 1, or do another subtraction, which is going to be -2 or -1 or 0. So those are the possibilities from this particular index, and as you can see, there are duplicate problems here which we have stored. Anything else? No, I think that's it. So for this particular problem, if you have any questions, please comment below. If you enjoyed this video, like and subscribe. If you want more videos, check the link in the description below. Thank you very much, and I will see you in the next one.